So what happens to this secondary water in any electrical power plant?
It's like boiled and then condensed continuously.
That's pretty much it, right? Flash to steam, and then turns back into water, gets condensed back into water, and then flashes to steam and turns back into water. So it's just a loop.
It turns the turbine.
Yeah. Flash to steam. That turns turbine. Then this isn't just a nuclear power plant. This is all power plants. It's just a difference in what causes the flash and steam. Is it hot water from a nuclear reactor, or is it a coal-fired plant? Or is it burning coal? Is it burning natural gas? So the rest of the electrical plant looks just like a nuclear power plant, except for the nuclear primary loop part. All the rest of it looks the same. Okay, so which carbon's organic?
The carbon with the -4 charge, right?
All carbon is organic, except which?
Because the -4.
The most organic is -4, but you're still organic if you're -2 or 0 or even +2, because what does it mean to be organic then? Um, okay, and the source of most of these organic molecules?
Living organisms.
Go with plants. How about plants? Or how about long dead plants? If your answer was fossil fuel, that's fine, but I mean, that wood out there that you could burn at your house, that's same situation. The reason it's burning is those carbons have electrons to give. Same way it's burning inside your car, because it has those carbons have electrons to give. Okay, how about this vital force theory?
It's the theory that organic molecules can only be produced within living things.
Okay. So Wooler created urea in a lab. And urea is a molecule that's made inside of a living organism, an organic molecule, so he just broke vital force theory. How is it that carbon can make 4 bonds?
More valence electrons.
But more specific than that. The hybrid of the 2s and the 2p equals 4 orbitals with 1 electron
Orbit. It's spelled today. Wow. So we end up with 2sp3 and since covalent bonds are overlapping of an electron from each of the atoms typically, so the carbon atom has those 4 electrons that can be situated in 4 different directions and thereby making 4 different bonds. Okay. Propane, draw out the, okay, so carbon, carbon, carbon. And then, so there's the structural formula, and then below that is the condensed structural formula. And you can see how the CH3s and the CH2s correspond to what the structural formula looks like. And then the line structure is just that upside down V. It's only showing you that there's a, that's a carbon, and that's a carbon, and that's a carbon. And then having you make the assumption that it's got to be connected to 4 things, and and we never draw hydrogens. You also might see this drawn like this. Because drawing all those H's is lazy, but maybe I want to show you something like there's a chlorine here, and it makes it a little bit easier. So all the blank spots, those are H's that haven't been drawn. Okay, so organic, what do you have for math?
1 carbon.
1 carbon. I don't know why that just happened. 2 carbons. Why is this disappearing? 3 carbons. 4 carbons. That's it. Could be a side chain, could be the main chain, but 1, 2, 3, and 4 carbons. The reason I stopped with those is, what's 5 carbons? What was 5 when we were doing nomenclature before? Pent. It's the same. So before it was mono, di, tri, and tetra. And in organic, it's meth, F, prop, and bute. But then everybody after that is normal. So pent, hex, hept, oct, non, dec.